All right, let's go ahead and shift gears a little bit. So far, we've essentially shown that there is a relationship, a linear relationship between the two variables, x and y, that we identified. But what we really want to do is we now want to go ahead and get more precise with what kind of relationship we got. And that essentially is what's called the least squares regression line. And the whole point of the least squares regression line is essentially instead of, it's basically a way of summarizing the data. Instead of giving all of the data points, I'm simply going to go ahead and give you the pattern that they appear to follow, the trend. And that is that goes by many names. It's the line of best fit is one of them. The least squares regression line is another. And essentially what we're doing is we're saying, you've told me that there's a trend, there's a linear trend. So what is that line? And again, that's called the least squares regression line. And it's simply a line that best fits the data. Now, to actually find this, you need calculus, because what you're basically doing is you're saying, if I were to make a line, so let's say this is the line, draw any line, actually, maybe a line that goes like this. And then what you do is you see how close is the data to your line. So you go from your data and you go vertically to the line. Data vertically to the line, data vertically to the line, data vertically to the line. And so remember, these are the deviations. Kind of like before, the line is essentially our average. And then what you look for is you look to minimize those deviations. So you find the line that minimizes these deviations. Really what we're doing is we're minimizing the square of the deviations. The deviations are called residuals. So if you have the data point here and you go to the line, then when you square it, multiply it by itself, you're essentially getting an area, something like this, because it's length, right? It's this length times this length. And you essentially go ahead and find the line that gives you the smallest area possible. And if you already took calculus, you recognize that there's actually an optimization problem where you go ahead and you say, out of all possible lines that exist, what is the value of the slope? So in other words, we have the equation on the line, y equals mx plus b. I believe the way that we're going to read it, it's going to be backwards. It's going to be y is equal to b plus m times x. And the question is, what is the value of b and what is the value of m? So from algebra, we remember that b is the y-intercept and m is the slope. Basically, the rise over the run of our line. And that's two values. So you actually need multivariable calculus to solve this because you have to optimize a problem. But for us, it's going to be pretty easy because we're simply going to use StatCrunch to find these values. So we're going to use StatCrunch to find the slope as well as the y-intercept. And it's so easy, in fact, that if you were to plot this, this is the way it's going to work. If I were to give you this actual data set, xy, 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 you're just simply going to go to stats, regression, simple linear, and in that output, you're going to see sales volume. Notice sales volume is the y variable. So in reality, what we have is we have that y equals 37461.59 plus 0.13. And then notice it's times advertising budget. Advertising budget is the x. So that would be the x variable right there. And so in other words, since it avoids using calculus and we just use technology to find the value of the y-intercept and the slope. And in this formulation here, you can see that the y-intercept is first of the line of best fit. And you can see the slope of the line of best fit. All right, so once you have an equation, you can go ahead and actually do one of the major things. So the equation itself isn't, what we're after, because we already know there's a relationship. It's really what you can do with that equation. And so here's one of the major uses for regression, and that's prediction. Because a point on the line, essentially, so if this is your line, any point on your line is a prediction. It says, if you were to give me an x value, notice in this equation, there's nothing stopping you from replacing x with some other value that you're interested in. So if you have a value of x that you're interested in, for example, in this case, it's 6, you plug that into the equation, and then check this out. The equation itself would give you a point right here and basically gives you a predicted y value. Whenever you predict something, we're going to put a little hat on top. So if x is 6, I predict that I'm going to get an output of 600. If, for example, I go ahead and plug in a value of 2, plug in 2 in here, you're going to end up on your line, and you get a value of roughly 420 or 430. So every point on the line has the form of x, comma, y hat. And that's really the main point, because a point on the line represents the predicted y value for any x value. Remember, the predicted y value is going to be y hat. So if that's one of the major uses, let's go ahead and actually see how simple this is. So here we have our first example. It's a scatter diagram, and it supports the claim that there's some kind of a linear association or correlation between a viper's length and its width. So we have our data point right here. And again, this is just data. If it were given to you, you can create the scatter plot. And we can see that the viper length is the explanatory. So according to the scatter plot, which variable is the explanatory? Well, it's right here, viper length in centimeters. And then viper weight is the response. Okay, so we got part A done. I went ahead and used technology, and we can see that the weight, in other words, the viper's weight, so the y variable, is equal to negative 11.03 plus 2.21 times the length, which is the x variable. So here we're basically asked, use the equation given to predict the weight of a new viper measuring 65 centimeters. So what I want to point out is that there is no viper that we measured that was 65 cent, or was there? Maybe that point might be 65, but it might, because of the decimals and stuff, it might not be exactly 65. All right, so use the equation below to predict the weight. Okay, so we're predicting the weight, so that's y hat of a viper measuring 65 centimeters. So that should be the length. So in other words, they're saying if x is 65, they're basically asking what is the y value. And remember that if we're predicting, we're going to call it y hat. So luckily we have our equation. So we have the weight is equal to negative 11.03 plus 2.21 times the x value. And we know that the x value here is 65. And if you look closely, this is simply an expression. So we can throw this into a calculator like Desmos, and we'll get 132.62. And we can basically eyeball this. So if x is 65, remember that whenever you predict, you're essentially landing on the line. So there's our value. And if you go horizontally, you end up with 132 point something. And notice that this is actually split into, skips are in twos. So that would be 133. So we're a lot closer to 133 to 132. So 132.6 does make sense. So the way that we're going to write this is that if x is 65, then we're predicting that the y value is going to be 132.62. Okay, so it's as simple as that. In order to predict, we simply replace the x value. Let's go ahead and try this. Let's see if you can do this. So in a previous example, we looked at the Gallup organization, tracking commute time, which was our explanatory, and the well-being score, which was the response. So find a linear equation that relates commute time and well-being score. So I'm going to go ahead and do this myself, and then I want you to try it. So here's the data. And remember, it was stats, regression, simple linear. So all the other stuff we're not going to do, just simple linear, because it's a linear regression. And you tell it what the x variable is, as well as what the y variable is. And that's all that you have to do. Go ahead and press compute. And you're going to get this screen right here that has a lot of results. So you aren't really worried about all of these tables down here. What you want to note is that there is an equation. So first we have the results. They're telling you what the x and the y variable are. And then they give you the equation. So here is the equation. Notice it says that well-being score equals 69.0296 minus 0.0479 times commute time. So this is your equation. If you don't like that, so if you don't like the fact that this is your equation right here, you can go ahead and recognize that the intercept, the y-intercept, is also given in this table. And so is your slope. So now you can go ahead and write it as the y value is equal to, we always write it as intercept first, 69.0296, and it's minus, sorry. To minus 0.04. Oh, I'm not sure what happened. So that's the slope. The slope always needs to have the x next to it. So we can see that that right there is our equation. All right, now that that is our equation, the next part says to graph this on our line. And I'm not going to ask you to graph it by hand because StatCrunch actually has this. So in the result setting, there's a little arrow down here. And if you click it, you can see that we have our scatter plot that we created earlier, but this time it has a red line. And that red line is called the fitted line. In other words, it's the equation that we created. If you want to do this a different way, so let me show you just really quickly. You can go to graph, and remember, we created a scatter plot, so that's how we start. And then what you can do is you can overlay a function of x. And what I like to do is I just like to copy paste these numbers. And then make sure you type in x after that. And that should do it. Oh. Well, I got to put multiply. And you can see how we end up with the exact same graphic. So it's a little bit easier for us just to simply use the scatter plot. All right, that does it for us. So we created that. And I want you now to go ahead and predict the well-being. I always like to remind myself that well-being is the y variable for an individual that has a commute time of 60. So notice that there is no person here that has a commute time of 60. Okay, so go ahead and try this. Predict the well-being score of someone that has a commute time of 60. So remember, you got to use your equation. And go ahead and do the same thing that we did previously. All right, so hopefully you replaced x with 60. And after throwing that into a calculator, you should end up with 66.15, roughly. Let me round to 2 decimals, 66.16, just for simplicity. All right, and let me actually go ahead and show you how you can use Stack Crunch. This is one of the most used, this is one of the most common uses of um, regression. So there's actually a built-in command that does this. If you go to your regression options, so let's edit this. We know that we want to predict, so just X and Y. But if you scroll down, there's a lot of additional options. And notice that there's this option here that says prediction of Y. So because it's one of the most common uses for regression, there is a built-in command for it. It says, what Y value do you want to predict? So in other words, all you got to do is give it the X value. And the X value that we have is 60, remember, because that's what I substituted for X manually. And if you press compute, scroll down, and you see here you have X value is 60. And then you have your predicted Y value, which is 66.155213. Round, just because there's, depending on how many decimals you take, you're going to get different answers. So it'll be 66.16. So that makes it very easy for us to go ahead and predict. All right, let's try this one more time. My commute time to work is actually around 18 minutes, 18, 19. So I don't know my well-being. I hope it's good. So if my commute time is 18 minutes, can you go ahead and predict my well-being score? Go ahead and do that now. And that'll be it for us. Thank you.